Regression enables us to determine the relationship between two or more things, two or more variables. Like we have x and what and y. How increase in x affects what? Increase in what and y. Are you following somebody? Let's say for example now, if I have yield of what? Of a plant as against what? Fertilizer. Against what? Fertilizer. These are what? Two different what? Variables. Do you understand what I'm saying? It is your fertilizer application that determines your what? Your yield. You get the concept? We call this what? X. We call this what? Somebody? Your Y. Anytime you see Y means what? Dependent. It means what? Dependent what? Variable. YS means what? Independent what? Variable. Are you following? Now, the general expression for where's that doctor? General expression for regression analysis is Y equals A plus BX. Y equals what? A plus BX. Regression analysis is used to establish what? Relationship between two or more variables. If I have let's say I have a straight line graph. Regression means what? A straight line. Every linear graph has what called what? A straight line what? Graph. Hope you're aware. We have different types of graph. We have linear, we have quadratic, we have cubic, we have sine graph. Whenever we have a straight line like this, it's called what somebody? A linear graph. This is also called regression what? Line. Are you there somebody? In advanced mathematics, it's called line of best fit. Line of what? Best fit. In graphing, this is the line of best fit. The line that best fits the graph. Are you there? So any straight line, every straight line, have a general form of what? Y equals to what? A plus what? BS. Where Y represents what again? What is Y representing? Dependent. Abi? Dependent what? Variable. YS represents what? Independent. In the what? Independent variable. Meaning that the value of Y depends on what? On X. Do you get the concept? Y can represent yield of a plant. X can represent what? Fertilizer. If I have, let's say, the value of X, if I have a general form, if I have, let's say, Y equals to 2X plus 4, this is also a what? A regression what? Equation. Or a straight line what? Equation. Regression means straight line. Every straight line graph have a general form of this. In fact, whenever the highest power of the unknown is equal to 1, it becomes what? A straight line. Look at this. General form is A equals what? Y equals what? A plus what? BS. If I have Y equals A plus BS squared, this is no longer a straight line or a linear graph. It's now quadratic. Because what quadratic means what? The highest power is what? Is 2. If I have 3, it means what? Cubic. Do you get the concept now? So generally, the first fundamental analysis, or sorry, expression rather, for regression analysis is what? Y equals to what? A plus what? BS. Okay. Now let's go. Unlike me. Now the first fundamental formula that we should take note under regression is this, Abi. Y equals to what? A plus what? BS. A graph of Y against X. A represents what? The intercept. The what? Intercept. B represents what? The slope. The what? Slope. Or the gradient. Or what? Gradient. Y represents what? Dependent what? YS represents what? Independent what? Okay. Can I explain this? Can I explain? Now listen. Slope of every regression analysis is given as n. Summation of x, sy, minus summation x, summation what? Y, divided by n, summation s squared minus summation x, all what? All squared. The slope. Your intercept, A, is equal to what? Y bar minus what? Minus BS bar. Are you there? Y bar is given as sum of Y over N. YS bar is given as what? Sum of what? X over what? Let's look at what? Correlation analysis. Correlation what? Analysis. This measures the level of strength. This measures the level of what? Strength. Level of strength between two or more variables. This measures the level of strength between two or more what? Variables. The level of strength between two or more variables. Regression measures what? Relationship between two or more variables. How one variable affects what? The other, right? But in correlation, it measures the level of strength of that relationship between two or more what? Variables. Like for example now, it's selling chemists drugs. At the same time selling akara. Is there a relationship? There's no relationship. That's where correlation comes in. It measures the level, the amount of strength of that relationship between two variables or two or more variables. Are you following somebody? Now, correlation, the symbol is R, and it ranges from -1 to what? To +1. Correlation has a symbol what? 1. The range of your correlation value must fall between what? -1 to what? To +1. Meaning that -1 is less than R, less than what? Somebody? 1. Do you get the concept here? Meaning the values between what? -1. So less than or equals to what? -1 less than equals to what? R, less than equals to what? Because -1 is included, right? Also what again? 1 is included. The number between -1 and 1 also what? Included. Like 0. What? 0.1, 0.2, 0.3, 0.4, okay, 0.9. I can also have what here? 0. I can have what here? -0.1, minus what? 0.2, -0.3, down to what? -1. This one is going towards what? 1, I mean. This one is ending towards what? -1. Do you get the concept here? So correlation value ranges from -1 to what? To +1. Note that when the value of R is equal to 0, this means there is no what? Correlation. When the value of R is equal to what? 1, this means there is a perfect positive correlation. When the value of R is, let's say R is between 0.4 to 0.9, this means what? There's a strong what? So it's 0.5 like that. So 0.9, this means a strong positive what? Correlation. When the value of R is between 0.1 to 0.49, this means there's a what? A weak what? Correlation. When the value of R is now equals to 0, it means what? No correlation. Right there. In the exam, they might ask you, differentiate between correlation and what? Regression. You know it now? What's regression? It measures what? It measures what? Measures what? Between some more variables. What of correlation? It measures the level of strength of that what? Relationship between two or more variables. Are you getting the concept? Can I clear here? Listen. Are you there? Correlation formula. Correlation what? Formula. The formula is given as R equals to N summation SY minus summation X summation what? Y divided by square roots of N summation S squared minus summation X all what? Squared times N. Not the same thing now. It's the same thing. N summation Y squared minus summation Y all what? All squared. Is it the same thing? There's no regression does not have this part, and there's no square root, Abby. Now let's look at testing hypothesis for what? Listen, this value here, stop writing first, stop writing. Correlation measures what? Amount of strength of relationship. Abby, the value here from the formula is called calculated what? Correlation value. This is what arrow word calculated. Are you there? If you are given a question, let's say in a tabular form, and you find your value of R, that R is subjected into what? An hypothesis. Do you know what I'm saying? You can't just make a claim that there's a, let's say after solving for R, you now have R as one means what? Perfectly what? Correlated, Abby? Or what is it? Perfect and positive what? Relationship. Is that not? This value you have here, you can't just accept it. It's like making a claim. You must have to subject that claim to what? A test. Called what? Testing what? Hypothesis. Are you getting the concept here? Like I can make a claim that this guy, maybe he's a boy. Someone else can come and say, no, he's not what? A boy. He's a girl. That first claim is called the null what? Hypothesis. That's the first claim. The hypothesis being tested is called the null hypothesis. Which is what? H naught. Abi? The hypothesis we are willing to accept if we reject the null is called what? The alternative. And it's called what? Somebody. So the testing hypothesis for correlation. Now, for correlation is H naught is R. Equals to what? 0. That's the null. For my alternative, H1 is R not equals to what? 0. Are you following somebody? This means no correlation. Hope you're aware. This means what? There is correlation. Are you getting it? If R equals to 0, this means what? No correlation. If r equals to what? If r not equals to 0, it means what? There is what? Correlation. This means our what calculated. Now, how do you test your hypothesis? There's what called critical value for what? Correlation. Critical what? Value. Critical value will be gotten from your correlation table. You would let me check Google. Type correlation table. Download it from Google. Type it on Google. Go to image. When you type it, you will see many of them there. Listen, I will solve the problem. You understand what I'm doing? Very simple. Listen. When you get to a critical word value, or we call it arrow word tabulated. Arrow word tabulated. This is called arrow word calculated. Are you there? Arrow tabulated. I'm going to use what we call degree of freedom, which is what? N minus what? 2. To find arrow word tabulated. I'll come back to this. But in your decision, in your what? Decision, if arrow calculated is greater than what? Arrow what? Tabulated. We reject what? HO and accept what? H what? H1. After getting your arrow calculated, you get your critical value, which is what? Arrow what? Tabulated. Arrow tab means your correlation value from your particular table. Get the value. Then compare your calculated with what? Your tabulated. If your calculated is greater than what? Tabulated. Reject what? HO and accept what? H1. If I'm to reject HO and accept H1, that means there is what? Correlation. Is that clear? Let's solve the problem. A poultry foreman, F-O-R-E, foreman, observe the following variation in the age. A poultry foreman, observe the following variation. Are you there? In the age and height of his birds as follows. In the age and height of his birds as what? As follows. Here we have age, X. We have height, Y. So let's go. Here we have 3. Here is 5. Here is 10. Here is 6, 8, 11. Here is 12, 6, 15, and 13. Height. We have 2. We have 4. We have 8. We have 4. We have 3. We have 7. We have 10. We have 5. We have 6. And we have 9. Using correlation analysis at a probability of 0.05, determine if there is a significant relationship between age, which is X, and height, which is what? B. From your calculation, determine point of determination. Point of what? Determination. Which is PD. And comment on it. And what? Comment on it. I will solve this question, then we'll go. Are you done? We are giving all the table there. Age, Abby. What's our age is what? X, Abby. That's our age, Abby. What's our height? 5. What's the value of our age? Let's bring it out. Give me the value. 3, 5, 10, 6, 8, 11, 12, 6, 15, 8, 13. Is that all? What about the height? 2, 4, 8, 4, 3. What is there? 10. In this column, I need SY. I need what? SY. Here I need S squared. Here I need what? Y squared. Do you know why? Because in the correlation formula I gave you, there is a space for sum of SY. Formula say R equals to what? Sum of what? SY. Remember that? Minus what? Sum of X. Sum of what? Y. Over what? Square root, right? Is that not? Of N. Sum of what? S squared. Minus what? Sum of what? X. All what? All squared. Times N. Sum of what? Y squared minus sum of Y. All what? So we need sum of SY. Which is this? We need sum of what? S squared. We need what again? Y squared. So let's go. What's SY? S times Y. 3 times 2 is what? 6. 20 be 80. What's 8 times 4? 24. What 3 times 8 times 3? What is 11 times 7? 12 times 10. 120. 6 times 5. 30. 15 times 6. 90. 13 times 9. 117. Okay. Someone should find sum of S for me. Sum of what? Y. Sum of what? SY. Let's find x squared. What's x squared? 3 squared. 3 squared is 9. What's 5 squared? 25. What's 10 squared? 100. What's 6 squared? 36. What's 8 squared? 64. 11 squared? 121 abi. 12 squared? 144, right? 6 squared? 36. 15 squared? 2 what? 2, 5. 13 squared? 169, right? 169. For y squared, let's go. 2 squares, 4 squares, 16. 8 squares what? 64. Sorry, what's 8 square? 64. 4 square, 16. 3 square, 9. 7 square, 49. 10 square, 25. For 5 square, 6 square is what? 36. What's 9 square? 81. Alright, let's go. Find the sum of s. I've been done that. This will help me. Find the sum of s. Let's find the sum of y. Let's go together. Stop writing. Find the sum. Sum of x. Sum of y square is what? Sum of y square is 400. What do you have there? 89. What's sum of y? 54. What's sum of sy? Give me accurate value. If your values here are wrong, to affect our reading. So be very careful while solving. 9, which one? S square. 929. What about sy? Y. 58. This one is what? 5. Are you guys sure? Take again. No. Sum of sy. Add up. Alright. Which one again? Let's verify this. Verify. Let's verify before we solve. Verify. Okay. Sy is correct. What of y square? Correct. What about this? Is it correct? It's correct. Now let's solve now. Can you verify? Correct. Which one? All of them. Okay. Recall that r is what? N and b. Sum of what? Sy. Minus sum of what? X. Sum of what? Y. Right? Over what? N summation what? Over square root, right? Of n summation what? S squared minus summation x. All squared. Abi? Times what? Let's go. N summation what? Minus summation y. All what here? All squared. Right? So let's put the value. R equals, what's the n? N is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No value, yes. So it's 10 times. What's the sum of our sy? 5, 8. Abi? Minus. What's sum of x? Times sum of y? 89. Abi? Times what's sum of y? 58. Divided by what? Square root, right? What's my n again? 10. Times, what's s squared? 929. No. Or what is this? Minus. What's sum of s all square means I will sum this, then square. What's 89 square? Give me the value. Sum of x all square means square of this. 7 what? 921. This way? Okay. Times, Abi. What's my n again? 10. What's my sum of y squared? 400. Minus. Sum of y all square means what? 58 square, Abi. What do you have there? 8 what? 3 what? 364. Okay, 364. This way, right? Okay. And let's finish up this. So R becomes what is 10 times 5 8? Is 580 Abi? Minus 89 times 58 is what? Times 58. What do you have? 5,100 and what? 62. Divided by square root. So what you do for me? Multiply this, then subtract from this. What's the value? Multiply this, then subtract. Meaning 9290 minus 92792 1060. Are you sure? Times. Multiply 400 by 10, then subtract from this. What do you have? 4,000 minus 6. Are you guys sure? Subtract the numerator. What do you have? 718 divided by square root of. Multiply this. What do you have? Give me the value 87684. That's right. What's the root of that number? So 718 over what? What's the root of this? 870684. What's the root of 870684? 933 point what? 45. Divide this now. 718 by 93.1045. What do you have? 0. What? Give me the value. 7695. Which is almost same as what? 0. What? 7, Abi? Okay. We call this value what? Arrow what? Calculated. Which is what? 0.7. Are you there, somebody? Look at this. This 0.7 falls in where? Strong, Abi? Strong and positive. Is that not somebody? Strong and what? Positive. Is that not? But I cannot say it is strong and positive until I conduct what? A test. Now listen. We have come to a conclusion that our cal is what? 0.7. Stop writing. I will not claim here. I'm not claiming here for you. What's the out calculated? 0.7. Abi? The next now is to find the critical what? Value of what? of R, abi, called what? R what? Tabulated. Is that not? At a degree of freedom, which is what? N minus 2. For correlation, your degree of freedom is what? N minus 2. For chi-square is what? N minus 1. So here is what? N minus 2. What's my N here? For chi-square, it is N minus 1. For correlation is what? N minus 2. So my DF, what's my N? 10, abi? Minus 2 equals to what? 8. What's our level of significance? That means my alpha is what? 0.105, abi? Then to get the out tabulated at my DF, which is, sorry, yes, my DF, which is what? 0. What? Sorry, DF, which is 8, abi? And alpha, which is what? 0.05, is equal to, let's take this out. In that four-figure table, you can, you check, give me the value, 0. What? 63, alpha was given now. So given as 0.05. 1.8 is okay. 1.8, abi? That is 1.9, right? Now look at this. Between our calculated and our tabulated, which one is greater? What do we say our decision? What decision? I said that if our calculated, if our what? Calculated is greater than what? Our tabulated, we reject what? H naught, abi? And accept what? HA. Is that not somebody? But before then, I will have just bring out my testing what first? Testing hypothesis. Testing what? This should even confess before you start solving this. This will confess. So bring it back. Yeah, to confess. So what is our testing hypothesis? H naught, abi, is R equals to what? 0. While H1 is what? R not equal to what? 0. Is that not? So since, abi, is what? Our calculated is greater than what? Our what? Tabulated. Is that not? We do what here? We reject what? H what? Not. I'm rejecting this one means there is no correlation, abi, and accept what? H1 and conclude that what? What's the question saying? Read the question for me. That means if I'm accepting this, if I'm rejecting this and accepting this, I'll conclude that what? There is a significant what? Relationship. I'll conclude that there is, abi, there is a what? Significant relationship between what? Age and what? Height. Between age and what? Height. You get the concept here? Because our calculated is greater than our tabulated. I will reject the null hypothesis and accept what? The alternative and conclude that there is a significant what? Relationship between what? Height and what? And age. Or age and height. Yes. It means I will not reject H1 and accept what? H4. If the reverse is not the case. Exactly. A new graduate because it's not the same testing hypothesis. This one we are applying testing hypothesis here. So in my next slide, I will not teach you a testing hypothesis. Yeah, we are applying it here. Do you understand what I'm saying? We also apply this in chi-square. But before I go into chi-square, I will need to teach testing hypothesis. I think what I will have taught you guys first should be testing hypothesis. Before you now, I jump too many things before coming into this side. We will come back. Be fast, That's right. Hope you understand this, Abby. I'm coming. Yes, you hope what? Calculated is the one you got from your calculations now, which is this one here. Is calculated. From the one from the table, which is this one. What's out tabulated? This out tabulated. Tab means from the table. Cap means from calculation. Do you get? But are we done with the question? Number 2 says no, we're not done. Number 2 says what? Determine the point of what? Point of what? Determine, Abi, and comment on it. Listen, stop writing. Point of determination is given as our what? Calculated what? Squared. That's the formula. Our calculated was squared. What's the value of our calculated squared? 0. What? 7 all what? All squared. Abi? What will it be? 0. What? 5929. Abi? So my PD in percentage, in what? Percentage will be what? 0.5929 times what? Over 1. Abi? Convert this to percentage. That will give us what? PD in percentage is what? 59 point what? 29 what? Percent. Do you get the concept? Now, comment. Hello. What does S represent? Is it age, Abi? What does Y represent? Height. Please pay attention. S is what? Age, Abi? Y is what? Height. S represents what? Independence. Y represents what? Dependence. That means that Y depends on what? On X. Is that not somebody? It means that the height depends on what? On age. Are you there? So to comment, it simply means that 59.29% of what? Of age depends on what? Somebody? Depends on what? On height. Sorry, I'm making a mistake. 59 point. Which one depends on each other? The height now, 59.29%, Abi, of what? Of height, right? Height of what? Is that bed or what? Height of bed, Abi? Depends on what? On the age of the what? Of the bed. Final what? Answer. Final answer. 59.29% of height of beds depends on the age of the bed. The same to just correct it. Depends on, okay, on the age, Abi? On the age of the bed.